Hello again. This is Ms. Nakiala. Today's lesson is 5.5a, Operations on Functions. So we are going to be adding, subtracting, and multiplying and dividing functions. Do not make this more complicated than it is. It is really straight up what it says. Okay. You do have to be familiar with this notation. F plus g of x means f of x plus g of x. They give you some examples here that you can look at. Okay. F minus g means subtract the two functions. F times g means multiply the two functions. You can see here. And then f divided by g, f over g of x equals, tells you to divide both of them. You do always have to remember that the denominator can't be 0, so that's something you have to include in your answer. All right, so for each new function, the domain consists of the intersection of the domains of both f and g of x. And under division, as I just said, you got to remember to exclude any values that make your denominator equal to 0. So besides the examples that you have up here, I'm going to do one more of each. So we have f of x equals x squared plus 5x minus 2, and g of x equals 3x minus 2. Find each function. So it says f plus g of x. That's how that's read. That means f of x plus g of x. F of x is x squared plus 5x minus 2. G of x is 3x minus 2. And y'all, you just combine the like terms. So that's going to be x squared plus 8x minus 4. That's all it is. F minus g of x is f of x minus g of x. F of x again, x squared plus 5x minus 2. Now this time you got to be careful because if you have more than one term in g of x, you need to use parentheses because you have to remember that that negative sign distributes to everything in your parentheses. So when you simplify this, you end up with just x squared plus 2x because the 2's, you can end up with a negative 2 and a positive 2. So the only thing that's going to trip you up on these is if not knowing how to combine like terms. That's all it is. All right, multiplying and dividing. All right, this is a little bit more. F times g of x is f of x times g of x. And I'm going to encourage y'all, when you had this on your most recent test, the people that did it using the box didn't mess up. But the people who didn't, I mean, I'm not saying everybody did. I'm just saying you might consider doing it because there are a lot of terms and you can get confused. So if I take the first one, which is x squared plus x minus 12, and then multiply by x plus 4, you'll remember the box, just the intersection, x squared times x times x, negative 12 times x squared times 4, x times 4, and negative 12 times 4. And then combine your like terms. You've got to go find those like terms if you do it, and that gives us x cubed plus 5x squared minus 8x, and then minus 48. Okay, f over g of x is f of x over g of x, or f of x divided by g of x. So my f of x is x squared plus x minus 12 over x minus 4. And most of the time you can probably leave it, but you do have to make sure it can't be simplified. In this particular case, the top factors to x plus 4, x minus 3. You still have x plus 4 on the bottom. Well, those are common factors, so that means this simplifies to x minus 3. And you have to remember what your bottom was originally, and that means that x cannot be equal to negative 4. So that's all there is to operations with functions. The next thing we have to talk about might be new. It is the composition of functions. And basically what you're doing is you're taking the results, wrong pen. You're taking the results, whatever. Come on, work with me here. Just good thing we love technology. Come on. All right. We're taking the results of one function and using those results to evaluate a second function. So here is a mapping of it. If I have an input and I put it into one function, I'm going to get that result and put it into another function. And that is what happens when we do it, it looks like this: f of g of x. Okay, it is written like that, but you want to know that that simplifies. If you see f with that little open circle, g of x, that means f of g of x. And if you remember correctly, whenever you calculate these, and we're going to do some examples, when you have multiple grouping symbols, we always start with the inside and work out. Okay. One of the things that becomes tricky on these problems is the domain. So what you want to remember, my inside function here, of course, is g of x. My outside is f of x. So I would do g of x first. But when you have to find the domain of a composite function or a composition of functions, you want to remember that the domain is the intersection of the inside and the result. So if the domain of my inside function was x equals 0, and the domain of my result was x, or x can't be 0, x can't be 2 or negative 3, then the domain of my combination or my composition function is going to be all three of those restrictions. So that's the kind of thing that you got to remember. All right, so let's go do some different kinds. We are supposed to find f of g of x, g of f of x, if they exist, state the domain and range for each composed function. So first off, for 3a, they just gave us a set of ordered pairs. So in these ordered pairs, I'm first going to find f of g of x. And y'all, I've been doing this many, many years, and I still write this next step, which says f of g of x, because I want to know where to start. So I'm going to simplify this. Some people don't need this table, and they can figure this out without it, and that's fine. But some people struggle with it. So I'm going to suggest that you use the table because I think it simplifies things. So first off, if I'm doing f of g of x, remember the first thing I do is x. And then I'm going to take x and I'm going to put it into g. And after I put it into g, then I'm going to put it into f. So my x values for g is up here. What are my x values? 4, 2, 9, and 3. So that's what I got. 4, 2, 9, and 3. I didn't mean to do that. All of that. Let's go with, 4, 2, 9, and 3. Okay. And then the g that goes with it is what I just had, which was 3, negative 1, 4, and 10. So we'll put all those in there. Okay. Now what I have to do is take g and go plug it into f. So if like this is my new x, 3, when I have x being 3, what does f equal? It equals negative 2. And when I plug in negative 1, I get negative 5. And when I plug in 4, I get 7. And when I plug in 10, I get 8. But the key, y'all, is the composition of the function is the beginning, what you started with and what you ended with. So the ordered pairs are going to be just those columns. So when I write that, my ordered pair is going to be, the first one is going to be 4, negative 2. Then I'm going to have 2, negative 5. Then I'm going to have 9, 7, and 3, 8. And that is the composition function of those ordered pairs. The domain is still just the first values, but we write them in order. Generally, if you give the domain of a function, y'all, especially in ordered pairs, you write them in order. So that would be 2, 3, 4, 9. That's my domain. My range, again, we're going to put them in order. So that's going to be negative 5, negative 2, 7, and 8. And that's our composed function. Now, that's f of g of x. Now let's go look at g of f of x. So g of f of x, I'll run out of room here. Let me come down a little bit. Okay. G of f of x, remember that next step because I need to know where to start. So in my table, my x values are still I'm going to start with x, but then I'm going to go to f, and then I'm going to go to g. So my x and f ordered pairs are 3, negative 1, 4, 10, and negative 2, 5, 7, 8. And then I go and I've got to put negative 2. I got to go find where's negative 2. Where's x equal to negative 2 up here? Well, it's not. So that means it's actually not defined at that point. If I go look for negative 5, not defined. 7, not defined. 8, not defined. So that means that g of f of x does not exist or is undefined. Either answer is acceptable. All right, let's look at 3b where we have two equations as opposed to a set of ordered pairs. So in 3b, again, I'm starting off with f of g of x, and that is f of g of x, okay? And now when I do this, we're going to go replace, we start on the inside, so I'm going to replace g of x. So that means it's f of what? Well, g of x is x minus 6. So now I'm going to go, what is the rule for f? Okay, so I'm looking at this as f of x minus 6. So I'm going to go to the rule for f, and instead of x, so first off, I write parentheses here when I do things like this. And I write the parentheses, and it says square whatever in parentheses and then add 2. And what's in my parentheses is x minus 6. And that's an acceptable way to leave it, y'all. That's vertex form of a parabola. You should know that. Quadratic equation, vertex form. The vertex is at 6, 2, and it goes up. And if you can visualize that, that should help you remember what your domain is. So my domain is all real numbers, and my range, if my vertex is at 6, 2, then it goes from 2 up. And I have a bracket on that. So that's my domain and range. Okay, but actually let's step back a second. Because remember, this domain is the combination of the inside and the result. So when you have equations like this, we do need to step over and go, okay, well, what's the domain of f? Well, the domain of f, that's a parabola, okay? The only restrictions we've had, y'all, is if we have a radical. And that doesn't have a radical, and that doesn't have a radical. So the domain of both of these functions is all real numbers, negative infinity to positive infinity. So that was safe for that one. It's not a problem. All right, let's go look at it going the other way. G of f of x. G of f of x is g of f of x. So I'm going to go replace f of x with x squared plus 2. And then I'm going to go put it into g of x. So when I put that into g of x, tells me take whatever you have in parentheses and subtract 6. So I'm replacing x plus 2 in there. And y'all, I have the parentheses just so that you can follow what's happening from one step to the next. But you do need to simplify that because it can be simplified. This, I don't have things, I would have to multiply that out. And you can do that if you want to, but you don't have to because that's an acceptable form of the equation. But this here, I can combine the 2 and the negative 6 easily. So this would simplify to x squared minus 4. Okay, so that would be what it looks like. And our domain, remember our inside was still all real numbers. So my domain is still going to be all real numbers. Okay, my range, on the other hand, what does that look like? That is a parabola that has been shifted down 4 units. It still goes up. So the lowest point is negative 4 all the way up to infinity. And that's my domain and range. Okay, last thing to talk about with this is, I love these because you don't need a calculator. Compose functions visually. Evaluate f of g of 3 given these two functions. So where do you start? Always start on the inside. So you're going to start with g of 3. Okay, so this is my g function. So I'm going to 3, which is right here, and I'm going to go find out what that equals. And not very well, but anyway. So g of 3 is equal to 6. So that means that f of g of 3 is the same thing as f of 6, because we just figured that. Now I'm going to go to my f function and go find 6 on my x. Okay, that inside number is always the x, y'all. And so I'm going to go up here and go, okay, well, what is 6? And y'all can see that that, of course, is equal to 6 also. So it's 6. All right, those are in Delta Math. You've got a video and examples if you still have trouble with that. But that's the end of operations on functions and composition of functions. Thank you so much for watching, and y'all have a great day.